Good morning. In this lecture series, we see about the stress. Already we discussing about the what is the understanding of global and local coordinates. Okay. Now we have to assumption of the stress, how to they form of the conditions, and we have to form the stress. We have to understanding the what are the assumptions we need to solve the stress problem. So first of all, so what is the meaning of trust? So the trust is nothing but is a structural framework composed the internal connected member that arranged in the triangular units. This configuration create a rigid and stable structure that capable of supporting significant load while using the minimal material. So the what are the common applications for the truss? As we already see the diagram, the bridge structures by, spanning rivers and highways, roof system for buildings and warehouse, transmission towers and communication masts, the stadium canopies, and the large span enclosures. So these are the application and what is the meaning of truss. So what are the component of the truss? So there are three components like a members, joint, and support. So the first of all, the members is less slender structure, the element that form the framework. So members are typically the made up of the steel or timber and are designed to carry the axial force, either the tension or compression. So while joining, the connecting points where two or more members meet and analyze join the assumes to be pinned connection that allow the rotation but prevent the translations. And also the supporting boundaries are the boundary conditions that connect the truss to its foundations. The support provide the reason for the prevent movement and ensuring the structural stability under the loading. So the next is a type of stress. The stresses may be classified into two. One is plane stress and space stress. So what is the plane stress? A two-dimensional stress where all the members and loads lie in a single plane. So this is the most common type of analyzed in the structural courses as it simplifies the calculation while representing many real-world applications. So the space stress is nothing but a three-dimensional stress with the members or originator in the space, and the space stress are used when the load acting in the multiple direction and the greater structural when the complex is a require such a transition towards. So the pin joint members, the truss analysis, we assume all the members are connecting by the frictionless pin joints. This means joints can be freely rotated without resistance, allowing the members to prevent pivot relative to the one another. So what are the key impact we are using is the no movement and the rotational force is a translator between the members. So as you know that the member we already learned that. So the only the axial force are transmitted through the connections and the joint cannot be restrict the bending or twisting. So these are the assumptions that greatly simplify the calculation because we don't have need to the account for the complex movement and the distribution at the connections. So the next one is the load acting at the joint. We assume that all the external load, whether the for snow and wind weight are applied exclusively at the joint locations. The self weight of individual members is either neglected or distributed to nearest joint. So why this assumption? So when the load acting on is the joint and the members are the pin connector, each member because two force members. So this ensure the force acting along the members axis and eliminating the bending effects and simplifying the force calculations. So the practical applications are so the reality, the members do have a self-weight distributed along their length. However, for the most truss, this weight is small compared to the applied load. Assume the joining load introduce the minimal errors and while the dramatically reducing the analytical complexity. So the two force members, the each stress members is treated as a two force member. That means that the experience force that only 2 points at the end points, these force acting along the members and the longitudinal axis. So the force type is what is tension and compression. So first of all, the tension is the member is bending pulled apart, elongating the slightly under the load. So what is the compression? The member is being pushed together, the shortening the slight under the load. So what is the excluder? So no bending within the members, no shearing force perpendicular to the axis, no torsional or twisting effect to the members. So the conclusion of this video, the structural stress analysis we have to classify as a definition and a simplification assumption and the mathematical formation and the analytical as approaches. So what are the basic definitions? Is a structural system, the straight slender member, idealization pin joint, axial force loading. The simplification assumptions, the frictionless pins, load and reaction at joint only, no bending and shear torsion, and the weightless member and the small deformation. So the mathematical formations are the equilibrium equation, stiffness of elation, and nodal displacement, and internal forces. So these are the summary of this class. We see in the next class about this class.